Okay, so let's take a moment and review some material from Chem 11. Let's say I've got a salt, like for example, sodium chloride, NaCl. Generally speaking, that will be a solid at room temperature. But we can put it into water, and we see that the polarity of the water is actually able to separate the salt ions. So the sodium ions, the Na plus ions, and the chloride ions, the Cl minus ions, go off into solution as aqueous substances and float around there. Now, this can only happen up to a point. This happens until the point of saturation. Eventually, we see that if we continue to add more and more and more solid salt to the water, the salt stops dissolving in the water, and instead the solid salt just sits there. And last year, you talked about more soluble and less soluble salts, and you looked at, for example, whether something like calcium hydroxide would dissolve or not when you placed it in water. So now we're going to look at this sort of situation, but describe it as an equilibrium. So now, as an equilibrium, we want to consider the fact that in the water, solid sodium chloride, NaCl, can be broken down into sodium ions and chloride ions. But also, those sodium ions and those chlorine ions can react within the water, collide with each other, and hold on in a way that rebuilds solid sodium chloride. So this is actually an equilibrium. The rate of the reaction in the forward direction is just based on a function of temperature. The rate of the reaction in the backwards direction is based on a function of temperature, and the concentration of the Na ions and the Cl ions, because it depends on the collision happening between these ions in order to go back in the other direction. So when I have enough ions in the system, the collisions will become common enough that the rate of the back reaction eventually reaches and matches the rate of the forward reaction. The rate of the forward reaction doesn't change if temperature stays the same. So it's fixed, and it's just a question of how long it takes before the rate of the backward reaction manages to match it. And once the rate of the backwards reaction matches the forwards reaction, then we begin creating sodium chloride, the solid, as quickly as we break it down, and we reach saturation. So saturation is the equilibrium where the forward rate equals the backward rate. Which means that just like we did for a chemical reaction, we can describe this physical process of dissolving something in water using the expression that some K is equal to the concentration of Na times the concentration of Cl. I've got a special name for the K in this case, where we talked about Keq in the past chapter, the equilibrium constant. We're going to talk about Ksp, the solubility product constant. Solubility, because we're talking about whether or not something dissolves. And product, because it turns out to have no denominator. We're just multiplying whenever we find one of these things. So this is a product, Na times Cl, so it is the solubility product constant. The higher this constant, the more we can dissolve Na, or whatever the substance is, in water. The lower this constant, the less soluble that the substance is. This is the idea that we will explore in class tomorrow.